pi bond. Pi bonds are formed by the sidewise. Pi bonds are formed by the sidewise sidewise or lateral overlap of atomic orbitals. Pi bonds are comparatively weaker than the sigma bonds. Pi bonds are comparatively weaker than sigma bonds. Okay. Pi bonds are formed by the sidewise or lateral overlap of atomic orbitals. Pi bonds are comparatively weaker than sigma bonds. Okay. This is the p orbitals plus p orbitals. Arrow mark up after overlapping this as like this. Okay. As like this is shown PP lateral are okay, pi bond, okay, overlap, this is overlap, pi bond is formed, okay. Single bond has sigma bond, double bond contains one sigma and one pi bonds, whereas triple bonds contains one sigma and two pi bonds. Okay. Single bonds, sigma bonds, single bonds, sigma bonds, single bonds, sigma bonds, double bonds, one sigma and one pi bonds, and triple bond. Where is triple bond? What is triple bond? One is sigma and two is pi bond, One is sigma bond and two is pi bonds. Okay. Thus in hydrogen fluoride HF, the bond is sigma, and oxygen, there are one bond and one pi bond, and oxygen have one is sigma and one is pi bond, and nitrogen, there are one is sigma and two is pi bonds. Okay. This is a hydrogen fluoride, one is sigma bond. Okay. One is sigma bond, and this is oxygen molecule, one sigma and one pi, one sigma bond and one pi bond, okay. And this is a nitrogen, One is a sigma bond and two is pi bond. One is sigma bond and one is sigma bond and two is pi bond. Okay. Characteristics of pi bond. Characteristics of pi bond. Characteristics of pi bond. Okay. This is weaker than sigma bond. This is weaker. This is weaker than sigma bond. This is weaker than sigma bond. Second point. Pi bond is formed only after the formation of sigma bond. Pi bond is formed. Pi bond is formed only after the formation of sigma bond. Only after the formation of sigma bond. Okay. Third point. It is not possible to rotate. It is not possible to rotate. It is not possible to rotate pi bond along internuclear axis. Internuclear axis. Okay. It is not possible to rotate pi bond along internuclear axis in terms of strength of covalent bond. Next heading, strength of covalent bond. Strength of covalent bond. Okay. The strength of covalent bond depends upon the type of overlapping. When the overlapping of orbitals occurs on one axis only, the bond formed is sigma bond. This is a strong bond. One axis means that the line joining the nuclei and the direction of overlapping are same. SS, SP and PP coaxial overlaps form sigma bond. The strength of bond is greater in PP coaxial overlap since the existence of overlap is maximum in this case. The relative strength of bond is in the following order. Okay. SS, SP 1.732 and PP coaxial 3. Hence the strength of covalent bond is follow as PP coaxial. PP coaxial bond is greater than SP bond is greater than SS bond and sigma bond is greater than pi bond. Okay. The strength of covalent bond depends upon the type of overlapping. Okay. When the overlapping of orbitals occurs on axis only, the bond formed is sigma bond. This is a strong bond. One axis means that the line joining nuclei and the direction of overlaps are same. SS, SP and PP coaxial overlaps form pi bond. The strength of bond is greater in PP coaxial overlap. Since the existence of overlap is maximum in this case, the relative strength of bond is in the following order: SS1, SP 1.732 and PP3 coaxial. Okay. Hence the strength of the covalent bond is follow. PP coaxial bond is greater than SP bond is greater than SS bond and sigma bond is greater than pi bond. Okay. Comparison between sigma and pi bond. Comparison between sigma and pi bond. comparison between sigma and pi bond. Okay. First point, sigma bond. Sigma bond. This is pi bond. Sigma bond. This is pi bond. First point. It is formed by the overlapping of. It is formed by the overlapping of orbitals along the molecular axis. Overlapping of orbitals along the molecular axis. Okay. As compared to pi bond, it is formed by the sidewise. It is formed by the sidewise. The sidewise. It is formed by the sidewise or lateral overlap of two p orbitals. Okay. Second point. The extent of overlapping is greater in sigma bond. The extent of overlapping is greater in sigma bond. Hence it is a stronger bond. Hence it is a stronger bond. Okay. As compared to sigma bond, pi bond is the existence of overlapping. The extent of overlapping is relatively poor. Hence it is weaker than sigma bond. Hence it is weaker than sigma bond. Hence it is weaker than sigma bond. Okay. Third point. The molecular sigma orbitals consists of an electron cloud symmetrical along the bond length. Pi bond as compared to sigma bond. Third point is the electron cloud in pi bond. The electron cloud in pi bond. The electron cloud in pi bond shield the atomic plane. Shield the atomic plane above and below. Okay. Fourth point. In sigma bond, the atom can be rotated. can be rotated along the bond axis freely. Okay. In fourth point of pi band, free rotation is not possible. Free rotation is not possible. Free rotation is not possible around the pi band. Okay, pi band, because the electron clouds overlap above and below, the plane of the atoms, okay, the plane of the atoms, hence it will be destroy the sidewise overlap of orbitals. Hence it will destroy the sidewise overlap of orbitals. Okay. Fifth comparing point. The bond direction is determined from the bond direction is determined from sigma band. It also determines the existence of bond length. It has no effect. On bond direction. It has no effect on bond direction. It has no effect on bond direction. When pi band is formed, the bond length shortness. The bond length shortness. Okay. This is comparing point of a sigma band and pi band. Okay. You have carefully shown this comparing points. It is very important as compared to competition and board exams.